This is Note Taking Guide 2.7 for Math 1. Today we are going to talk about how to graph systems of equations and how many solutions they can have. So really what can happen here is we can have one solution. When we say that it has one solution. We also would say that that solution is an ordered pair. So an x, comma, y. When we look at a graph of that would be, say we have a line coming this direction. We have a line coming this direction. We have one specific point of intersection on those two lines. That point of intersection would be an ordered pair, and it would be one solution. Okay. Another thing that we can have happen is that we can have zero solutions. The terminology for that would be no solution. In math, we sometimes use that zero with a line through it to represent no solution. And when will that happen? That will happen when we have two lines that are parallel to each other that will never touch or cross each other. So two parallel lines are going to make no solution. Okay. The other thing that can happen is we can have infinite many solutions. I'll just gonna put the infinity sign there. There can be infinite solutions, meaning most of the time we call that many solutions or all real numbers. When that happens, we graph a line and then we graph another line and it ends up being right on top of that first line. When that happens and we have the exact same two lines, that means every ordered pair along those two lines will be the same, which means we have many solutions or all real numbers or infinite solutions. Okay. So what we're going to do today is we're going to graph some of these and also talk about their solutions. So A right here says tell how many solutions we have. Well, we have a line that intersects a line right there. Anytime they intersect each other, we have that one ordered pair solution. So this would be one solution. Over here we have these parallel lines. Parallel lines are never going to intersect each other, so this is no solution. You can write it with that symbol, or you could write the words no solution. Okay. So let's graph some now ourselves and see what happens when we graph them. So if you remember when we graph lines, we're in the slope y equals mx plus b form. So y equals mx plus b, where m is our slope and b is our y-intercept. It's where we cross the y-axis. So we always start at that back number that's added or subtracted. That tells us where to start on the y-axis. This direction is the x-axis, up and down is the y-axis. So this number back here tells me where to start on the y-axis. This number tells me my slope. So I'm going to start up at 3 on the y-axis, and I'm going to draw an ordered pair right here. Okay, from there I'm going to follow my slope. This slope in front is 2 over 1. So my rise is 2 and my run is 1. So from this ordered pair that I started at, I rise 2 and I run 1. I rise 2 and I run 1. And my line's going to go through those ordered pairs. Not the best straight line, but hopefully we'll be able to see where our point of intersection is. Okay, my next line starts at 2 on the y-axis because that's where my y-intercept is. And then the slope is the number out in front of the x here, which is a 1, so 1 over 1. So from there I go up 1 and over 1, up 1 and over 1, up 1 and over 1. And I come through like this for my line. Now again, like I said, I did not do a very great job on graphing these like straight, so we kind of have to just guess where our point of intersection is going to be on this, but I think it's pretty obvious to see where they would have intersected at. If I would have gone over, down 2, and up 1 over 1 on this one, they would have intersected right here at this ordered pair. That ordered pair is -1, 1. So we solve that system of equations by graphing and finding the point of intersection. Okay, we're going to do the same thing on this next set. We're going to graph them. We're going to see if there's a point of intersection or if there's no solution or many solutions. So again, we're starting back here at 5. So we go up to 5 on the y-axis, and then we follow our slope, which is up 1 and over 2. So up 1 and over 2 from there. Up 1 and over 2 from there. And my line's going to go through those ordered pairs. Then I'm going to graph the second one. There's nothing back behind here, so I'm going to start at 0 this time. My goodness, I'm having a hard time writing a point there. And then I'm going to follow my slope, which is down 2 and right 1. So down 2, right 1, down 2, right 1. So if I were going to go the opposite, I could go up 2, right 1, up 2, right 1. And again, if I would have been able to draw these lines perfectly, which I can't on my iPad here, I would be able to tell exactly where those points of intersection is. But to just kind of follow, let me see if I can follow my slopes a little bit better. So this was up 1 over 2. So if I went the opposite direction, it would be over 2, down 1, over 2, down 1, over 2, down 1. So that slope would have gone through there. This slope would have gone down 2 over 1. So I would have been going from here up 2 over 1, up 2 over 1, up 2 over 1. So we can actually see the point of intersection better that way if I did that. So it's right actually over here in this spot right here. And that ordered pair would be -2, 4 for our point of intersection. So it's important on graphing and to be really exact and careful. Graphing is the first way we teach you how to solve these systems of equations. We're going to show you some other ways. The other ways are with algebra, which are clearly more efficient than trying to graph. I think sometimes when we're graphing, it's a little more guesswork than it needs to be. But anyways, this equation, this system of equation has one solution. All right, these next two equations are not solved for y, so we're not actually ready to graph these yet, which means we got to do some work. So on this first one right here, that 2x plus 3y equals 12, we have to solve that for y so we can graph it. So we got to get the 2x over to the other side, which doesn't actually combine with that. I just need to write it as -2x plus 12. And why did I write the 2x in front? Well, it's because I want in that form y equals mx plus b. So I wanted the x's in front of the number so that it was in that right form. Then I'm going to divide every part of this by 3 so that I can get y by itself. So I have y equals, I divided by 3 here, so that's a -2/3 x. And then 12 divided by 3 is a +4. So I finally have an equation that I can graph right here. So let's graph it and then we'll go and solve the other one. So we're starting up at 4. And then we're following our slope, which is down 2 and right 3. So down 2, right 3. Down 2, right 3. So here. Down 2, right 3. So here, my line's going through those ordered pairs, something like that. Okay, let's solve the next one, and then we'll see if we can find a point of intersection if there is one. Okay, again, trying to solve for y, so I'm going to subtract that 2x over to the other side. I get a -y equals a -2x plus 4. I'm going to divide both sides by -1 to get the y by itself. So I have y equals +2x and then a -4. So I'm going to start down here at a -4. I'm going to go up 2 and over 1, up 2 and over 1, up 2 and over 1, which is where I should have been right there. This line goes through those ordered pairs, and I can see that my point of intersection is 3, 2. So it does have one point of intersection again. Okay. All right, this last one, these are horizontal and vertical lines. So let's just remember how we can tell. This one says y equals -4. So we go on the y-axis to -4, which is right here. And y would be -4 all the time straight across right there. This one says x equals -2. So I go over on the x to -2. And my x's would be -2 all the way up and down right here like this. So again, this has only one solution, one point of intersection, and that's going to be -2, -4. That wasn't a very good thing to write with. Okay, so all of the examples today only showed that you had one solution, but we can, again, just to remind you, if you graph two lines and they're parallel, that's going to be no solution. And if you graph two lines and they end up directly on top of each other, that's going to be all real numbers or many solutions. So don't forget that that can happen even though the examples that I show you today did not show that. Okay? All right, thanks for watching. Good luck with your homework, and make sure you do the rest of that checkpoint and check it with me to make sure that you are doing it correctly.